Okay, so we got this situation. How many ways the word equation can be arranged so that all the vowels will always come together? Okay, so this type of question is named as tie and gap method. Okay, means there will be some situation in which there will be some letters which wish to come together always. Like suppose that in your classroom there exist 5 members. Okay, out of those 5 members there are 2 members who always wish to be together. Okay, so how we will handle that situation? We will use concept of tie. We will put them into a box. Okay, and then we will treat it as single element. Okay, now in other case what will happen, there, like out of those 5 members there will be 2 specific members who do not want to sit together. So if they will sit together there will be a problem. So what we will do, we will apply gap method, means we will ask them to sit in the gap. Okay, so this is tie and gap method. Now slowly we will understand the concept. This is the idea, rough idea. Now let's try to handle this question. How many ways the word equation can be arranged so that all vowels will always come together? Look at this. So vowel wish to come together. So E, Q, U, A, T, I, O, N. A, E, I, O, U. Okay, so this is vowels. Okay, this is your vowels and this is your consonants. Now look at this. Vowel always come together. So what we will do? We will, like, this is tie method. So what we will do? We will put E, U, A, I, O into one box. So this is box number 1, and then Q, and then T, and then N. We will treat this box as single element. Okay, now we have how many members? Member 1, member 2, member 3, and member 4. Now we will arrange them. So required number. So required number is, there are 4 members. So 4 member will be arranged in 4 factorial ways. Correct? Because there is no repetition. Now if you'll observe this box, internally all the letters, these 5 letters, can arrange themselves. Okay, so multiplication, because our task is not completed and there exist 5 elements inside the box, so inside box thing will be permuted as 5 factorial. Okay, so this is how these are the number of ways in which we can solve this problem. Okay, here there are certain elements which wish to come together, that's why we put them into a single box and we will treat that box as single element. Okay, now let's move on to next illustration. If the letters of the word equation are arranged, find the number of arrangement in which no two consonants are adjacent. So in this question, consonants is having problem. Okay, so E, Q, U, A, T, I, O, N. So this means these person are having problem. So here we will apply gap method. Required number. Now what I will do, first I will arrange these vowels. Okay, so there exist like E, E, U, A, I, O. So there are 5 letters. So 5 letters will be arranged in 5 factorial ways. Now if you'll observe, we, like, these consonants are having problem, they do not wish to come together, so what I'll do, I'll be using gap method. So because of these 5 members, we have created 6 gaps. Okay, because it is linear arrangement na. So if it is linear arrangement, the number of gap would be one more than the number of person. So there exist 6 seats. And how many seats do we need? We need 3 seats. So we will select 3 seats out of 6 seats. So 6C3. Now we have to arrange these 3 letters. So these 3 letters will be arranged in 3 factorial ways. So this is the required number of ways in which these consonants will never come together. Okay, so this is gap method. Okay, so if some person wish to come together, apply tie method, in which you have to put both things in one box and then arrange. If you are dealing with uh, will not come together case, apply gap method. In that, the thing in which you don't have any problem, arrange them first, then count the number of gaps. In those gaps, select the required number of gaps and then arrange those persons. I hope the idea is clear. Okay.